Thanks, Cass. So thrilled to have all of you here today. Before we get started, I want to say we're here gathered today really to talk about, one global emergency in climate. We'd be remiss not to acknowledge the emergency that erupted in Ukraine last night or overnight. We know we have folks from all over the world dialing in today. We hope you're all safe. Please take care of your family, friends, and team members today, and in the coming weeks and what's going to be, I think, disruptive times. So, okay. So, I think we had almost 1,000 people register for this today. So I think one of the things that I wanted to mention is it is now obvious, and I think it obviously should have been obvious a decade ago, but now it is very obvious that climate change is really the motivating problem of this generation. I think there's been a couple things that have happened in the last 5 years or so, 10 years or so that have sparked this kind of obviousness. And I want to mention one in particular, which is, the success of Tesla as a company has sort of opened the eyes in the world to, if you bet on certain changes that are going to kind of be inevitable in a decarbonized economy, and you pick the right winners early, you're going to see trillion-dollar companies get built. Right. And Bill Gates just said, I think 2 or 3 months ago, that he expects 8 to 10 Tesla scale companies in climate. So 8 to 10 trillion dollar companies being built. And some of those will be new companies like a Tesla. And I hope we have some of those entrepreneurs on the call today. And some of those are going to be existing companies that reinvent themselves, right? That say, well, in a decarbonized world, this is what my industry is going to look like. And I'm going to bet on it before my competitors do. I'm going to remake my large company, in this way. And I think, I hope we have those types of folks on this call as well. And from my perspective, synthetic biology ultimately is going to be one of the enabling technologies for this revolution. I expect, my estimation will be about half of those 8 to 10 sort of Tesla scale companies should be biotech companies. And you're going to hear from that. We have 3 great panels today. And so on the first one, you're actually going to hear a little bit about why that is. Why is biotech such a good fit for the challenges in climate, right? And I think one of the big reasons is just by nature of how biology works, it's really, really good at putting carbon together, at forming carbon-carbon bonds. And I was a chemical engineer. Let me tell you, in synthetic chemistry, we are not good at this. And so this is one of the superpowers of biology. And biology also runs at global scale, right? It makes the oxygen in our atmosphere today, right? And so I think fundamentally biology has that. You're going to hear from Patrick Boyle at Ginkgo, Dan Goodwin, who's recently at MIT, and Sarah Sklarczyk, now at Voyager Ventures, but previously at MIT working on climate. You're going to hear from them about some of those superpowers of biology. Our next panel with Cynthia Collins from here at Ginkgo, and Gaurav Chakrabarty at Solugen, and Nelson Barton at Genomatica. Genomatica and Solugen are 2 companies that are bringing synthetic biology, biotech solutions to scale in the renewable chemical space. And so, what can we learn from what they've learned, right? What's been hard when you actually have to deploy biology and biotech at the kind of scales that are relevant in climate. And then our third panel, with Jen Whiff from here at Ginkgo, Maddie Hall at Living Carbon, Kristen Ellis at Lower Carbon Capital, longtime friend. They're going to talk about who's funding this stuff. Right? How do you get new climate startups funded? Are there emerging businesses? Can you get paid as a new startup company in climate to take carbon out of the atmosphere? How does that work? What's that evolving market look like? Right? And so I think these are some of the panels we wanted to showcase today. But really, the main event is after those is we're going to have breakout sessions. Right. And so we're going to get to hear from all of you. There's a carbon capture and sequestration, regenerative agriculture and resilient ecosystems, designing negative and low carbon products, or just an open networking room where you can go and try to find, learn more about Ginkgo, or also go find, maybe a co-founder for your carbon neutral startups. So, and we've had great success with that. We held an event like this, probably 6 months ago. It wasn't 1,000 people, but those breakout rooms are really a big part of where you get a chance to get to know each other. Okay. Last point I'll make, Ginkgo's putting this on. So for those of you that are new to Ginkgo, I just want to explain briefly how we could help you. And so we're really a platform for deploying synthetic biology for programming cells. And the idea behind Ginkgo is very analogous to like Amazon Web Services. If you wanted to start your website, you wouldn't have to today think about how to build servers and run, keep those up all the time and up, you're just going to pay Amazon Web Services to handle that sort of centralized infrastructure. Well, that's what we do here at Ginkgo, but for synthetic biology, right? So I'm here in our offices in Boston. We have about 200,000 square feet of automated lab infrastructure that's very, very good at genetic engineering of cells. And so you don't have to build that. If you have a, climate application in mind, if you're a new startup and you don't want to have that big spend on an R&D lab and all that equipment and infrastructure, don't bother, right? You can just pay us to do that work. And in fact, customers of ours like Motif Foodworks, which is in the animal-free meat space, which is a big carbon reduction space, have had a ton of success. They just raised $250 million this past summer. They've never had to build a biotech R&D lab. They were able to just use Ginkgo's infrastructure as a variable cost to do their biotech R&D. Okay, and so that's sort of the general idea. We are making it easier and easier for people to get on our platform. So, for example, if you're a startup company, we're able to take equity in your company in lieu of cash in order to pay for our services, because we know that cash is particularly tight when you're a small company, especially in our environment today. So we will work with you to make it really easy, and we get folks on the platform in a matter of weeks. That's gotten a lot easier as well. And so really want to help those small companies. But if you're a large company, today we work with companies like Roche. We work with Bayer. We have a $100 million joint venture in nitrogen fertilizer production via biotechnology, which is another big carbon project. Work with folks like Givaudan. So some of the really largest companies in the world that we've engaged with, again, to help them deploy synthetic biology without having to hire a whole R&D group or figure out, bring all that technology in-house. They can just leverage us as infrastructure at a distance. Okay. So if, any of that's exciting to you, please don't hesitate. I'm at jason@ginkgobioworks.com. I will say personally that I have a couple kids. I have a 7-year-old and a 9-year-old. Look, this is the problem of our generation, right? If we fuck this up, it's a big, it's a problem for the world. It's not a problem we made, to be frank, but it's on us to fix it for the people that are coming after us. And so I'm so thrilled, to have so many of you here today that are fired up to work on this problem. We here at Ginkgo want to make you successful. We want to make you those next Teslas. That's your business. You're the apps. We're really a platform to support you. So really thrilled today to get in and learn what you want to work on. So thanks everybody, and enjoy the day today.
All right, thanks, Jason. Okay, well, let's dive in. I'm going to bring up Patrick, Dan, and Sarah to talk about synthetic biology and how it can play a role for climate action.
Thanks, Cass. Hi, Dan. Hi, Sarah. So yeah, thanks for that intro, Jason and Cass. I think for this session, we have a tall order in front of us. I think we have about 20 minutes to determine how synthetic biology will sequester gigatons of carbon dioxide from the atmosphere. So yeah, let's see what we can do there. But seriously, I think for Dan, Sarah, I'd like both of you to introduce yourselves in a second. But when you do, I'd like to hear a little bit more about what drives you to tackle a task this large. How did you get here in your career, and what are you looking for today in terms of building the right teams that can make a dent in the climate challenge. But before I launch into that, I'm Patrick Boyle. I'm the head of code base here at Ginkgo. I'm responsible for what we call our biological code base. This is the reusable biological assets that we deploy for our programs to help our customers develop products more quickly. So one example being, we have a product called the Protein Cell Development Kit. This is a way to help customers that are interested in making recombinant proteins using synthetic biology get up and running faster. And I'm also responsible for the folks who carry out our customer-facing projects and would work with customers of Ginkgo's platform to help make their applications a reality. So, with that, I'll throw it over to both of you to give me a little bit of background on how you got into climate in the first place. And Sarah, I'd like to start with you.
Thanks, Patrick. So I got my start actually as an entrepreneur. So building companies mostly focused on mitigation. Always wanted to work on stuff that matters. Clearly, lots of stuff matters in the world, but it became increasingly clear that in the time frame of my working life that I have ahead of me, climate is the most important problem that I could possibly focus on. So I've been really increasingly spending my career there. Got my start co-founding a car sharing company called Get Around. Also worked at the first lab-grown meat and lab-grown leather company, Modern Meadow. Realized that I should probably learn some more about the gaps in our decarbonization technology. So I joined the graduate program at MIT, which is where I was working alongside Dan and other fantastic colleagues. And really there I focused on what I saw as a really big gap in our capability in terms of what we need to do to stabilize the climate on the time frame we have, which is how do we get to gigaton scale atmospheric carbon removal? And I focused on assessing pathways we could build that leveraged bioengineering, since biology is the largest mediator of the global carbon cycle. So that was my path there. And then I also saw the opportunity to support companies that are at the cusp of commercial scale. And so I co-founded an early stage venture firm called Voyager, where I'm the co-managing partner, and we back early stage teams building foundational products to decarbonize the global economy.
Cool, very cool. Dan, how about you?
Hey guys, and I hope you don't mind me going on mute. We have a 1-year-old in the background about 30 feet away from me. Hey, so I'm here because of Sarah, actually, because 3 years ago, she was kind of my gateway drug into thinking about climate, because the way she was talking reframed climate as something I avoided, which was looking at photos of dead polar bears and feeling like shit, or reframing climate as, hey, there's a series of huge technical challenges that are worth working on, both because it'll be funded by government philanthropy, but also because there's very large upside downstream for people that can nail it. So the way, how I got to that beachhead was formerly I was a software founder in Silicon Valley. I dropped out of a PhD at Stanford. I was an entrepreneur in residence at IDEO, global product design company. Started my company in about 2012. Microsoft ended up buying it. And I think very similar to what Sarah was talking about, I think all my biggest heroes in life are the people who pick one or two things and put decades and decades into it. And by a mixture of luck and timing and all other external factors, they end up doing something meaningful. So for me, in 2013, I thought, okay, it's going to be neuroscience. Like neuroscience is the most important problem that we can do. And that was the PhD I'd originally dropped out of. So it's kind of funny for me, that computer science is my beachhead to neuroscience, and neuroscience is my beachhead to synthetic biology, which is my beachhead to climate. But what got me so excited about that is that from someone who was in the rapid growth of the computer science community in, say, 2009, 2011, 2013, where we saw the mobilization of a bunch of scientific talent turn into fantastic founders. Then I started seeing the synthetic biology community go through the same thing. So from starting my PhD in 2015, to see the sophistication, the way synthetic biologists started talking, they stopped talking like this could be a science paper to like, oh my gosh, like we solved this. This is $1 billion health business. And then now we're also seeing the same thing of like, this could be $1 billion materials company or that. And so for me, like what I'm currently just working as an independent scientist, working on these exact problems, specifically thinking about how we grow this, this ecosystem of science and entrepreneurs really at the earliest stage. Because if there's one thing that I think we can really do better, and why I'm really looking to Ginkgo to really help nail in the community, is how to make these problems both tangible in terms of like, this is where you would start doing these problems. And we can talk about rock weathering, enhancing photosynthesis, et cetera, but then also to articulate where the frontiers are. So, and I think this is going to be another tension. It's like, yes, there's a lot of things we might be able to work on, but we also want to figure out what are the most important things. And so for that, I think there's a lot of ways to approach this, but I definitely think about what is the tangibility layer? Like, how do we get people started working on this? And there's other fields that have done this really well, computer science, health focused, biotech. Then also, what is this frontier of like, what are the highest leverage things we work on?
That's great. Yeah, something I'd like to explore with both of you is, you both talk about, basically identifying, a large challenge in terms of climate, training as a scientist, and then working as an entrepreneur to try to bring, the right folks together. And I think, one thing that I've kind of, noted is that, it's been a bit of a journey to get here. So I did my PhD about 10 years ago. Biofuels was in vogue at the time, still is. But a lot of the work that I was doing, I remember feeling really limited by the tools I had at my disposal. So, today at Ginkgo, we use a lot of software and automation to do things in extremely high throughput. When I did my PhD, basically the amount of progress I could make on my metabolic engineering work for fuels was dictated by how quickly I could pipette and how many plasmids I could build per day. And I bring that up not just to talk about synthetic biology tools, but I know both of you have been observing basically the confluence of many different technologies that have been advancing over the last decade. Dan, you mentioned geology, for example. So I'd be interested in hearing from each of you with respect to what type of tools are being developed in adjacent industries to biology that are making this more practical today? Because, on the one hand, you have the urgency of climate. On the other hand, this question of like, okay, what can we do about it? And what are the fields that need to come together to make this happen?
Yeah, so happy to jump in there. There are specific technological tools, but I also want to highlight that markets are evolving in a way that's really transformative and powerful and critical here. So for companies pursuing solutions in, say, carbon removal, right, the development of markets that will actually pay for that carbon removal and an ecosystem of additional partners that can do verification, tracking, that can facilitate sales, operate sequestration resources. They're all absolutely terrifically important. That market has just really started to evolve. I think we're going to see a lot of movement over the next decade. Everything from advances in the 45Q federal tax credit. We're seeing a carbon price in the EU surpass 100 euros a ton for the first time in the 16 years that markets existed. I mean, these are really important pricing signals that both tell startup entrepreneurs, hey, there's a real business to be made here. I mean, there's potentially $1 trillion business to be made here. And it also is a signal to partners that will be the facilitators and the ultimate buyers of that carbon storage.
And then I can take the other side of that, which is maybe like the technical growth that we're seeing. I think that we're gonna we're gonna see a lot of computer science obviously coming in, right? That's kind of like the throwaway, but I hesitate to say it because it even feels so obvious. But there is this opportunity to look at synthetic biology as engineering molecularly precise machines. So once you think about that, you start bringing in a lot of the existing infrastructure, like you've got the Facebooks, like Facebook's got its protein group, Google's got its protein group, Salesforce has its protein group, which is great. But then you've got the other sides too, which is that, like as Sarah mentioned, there's also like heavy industry that has a lot of role to play here. The way I think about it a lot is like, what are the most productive communities in terms of founders, growth of businesses, et cetera, and then how do you replicate that? And so, I mentioned computer science, biotech for health. The other one that I say, which is just so funny, but like I think it's really informative actually, is the jiu-jitsu community, because like it's this world where people can all test their stuff because everyone's got mats, and then there's this way of disseminating ideas, which is through YouTube, and then that's highlighting the people who have become really good at disseminating good ideas end up becoming very well rewarded. And so I think where we're going to see a lot of obvious things happening is I think like scalable protein engineering for specific like molecular scale problems. So rock weathering is something that we have a community working on. But then it gets to the next part, which is that, okay, like let's say you can design something from a molecular bio perspective, you got the super fancy protein, you've got to cross the valley of death. And the valley of death exists in one, in people who work in therapeutics will speak about that normally, like, at the translation stage, maybe to humans. The valley of death, I think, in climate relevant companies ends up a lot, like, I think happens a lot earlier in terms of like, yes, you can do something that works in this little E. coli in this Petri dish, but now show us this, show us a kilogram scale like problem. And I think, what does it mean to be, like, what skills and industries do we have to bring in to rapidly be crossing that? And once again, I think Ginkgo has a big role to play. I think the chemical industry has a big role to play. I would love to see people like the mining industry, the petroleum industry. I think those guys have actually been really active. And as much as I think some parts of the climate community want to talk shit on the big heavy industries, and sure, there's something to be said, there's also a different way of looking at it. It's like these people actually, there's a lot of good people there that are actively trying to contribute, and they represent very big levers. So I would just urge, if there's anyone out there, is like sometimes we have to drop the purity and really think more pragmatic, and there's good people that want to add value.
Yeah, that's great. And in terms of, you mentioned like, crossing the valley of death, and, Sarah, I know you did your master's thesis looking into basically road mapping, bioengineering as a solution for climate. And now as an investor, how do you work with companies, and how do you think about what kind of the right scale of demonstration is to really build conviction in a particular technology, right? Because it's a massive, climate is a massive problem, but how do you find like the minimum viable product for these companies to develop that convinces you to invest and to bring other folks into the company?
Yeah, I mean that's a probably the most critical challenge for any early stage company. Usually by the time you're out seeking your first venture funding, you've demonstrated something works in the lab. Like, here's a proof of concept, here's a proof of principle. We can engineer this pathway, we can produce this molecule of interest. But that's not a business. What's going to be a business is, can you do it at scale at a cost that's competitive or advantageous to the fossil fuel incumbent? If you can do that, right, you've got a lever to change an entire industry. It's super, super exciting. And so what we are very glad to do is to help founders, clarify what that path looks like, to help connect them with existing service providers, big companies, for example, like LanzaTech, or other partners, depending on what target the company's looking at, who can really help them map out, help them do a technoeconomic analysis of what does scale up look like for us, and how does this become an excellent business? And, if it doesn't pencil out on paper now, what can we do to change our process and push our thinking? I've had to do that a few times myself, working at early stage companies, and everybody has to go through that. There's always going to be challenges you didn't anticipate. There are always going to be things that are sort of naturally advantageous to the process you've picked, and things that are more of an uphill battle. And the best thing you can do as an early stage founder is get a handle on that early. Dive in early. Do the rigorous work, bring in partners, tell people what you're doing so that they can point out, they can red team it, they can point out, where you could approach something differently, where there is a process from a completely different industry that you could look at adopting or repurposing. And when companies do that well, right, that's where it really takes off.
So I love that, Sarah. And if I could just jump in with something, I think one thing that we're really good at is workshopping startups. At least that's a very mature idea that people know. I think we could be workshopping science projects at the earliest stage, right? I like the Schmidt Futures crew, use the phrase "big if true." And if you're going to start something really, really early, I love the idea of really workshopping this. Like, what's the big if true, right? We look at the scientists and tell me like, okay, how would you de-risk if true? But then how do you work with the people who can speak to the scale side of it to confirm that it's big? And I think if you can work at the earliest stage to confirm this hypothesis that yes, that's big, then I think that's a way to actually start kickstarting kind of more productive science projects. Because one thing, I spend a lot of time looking in the geological world, right? And actually, and Patrick, you mentioned this briefly, but people with geology background, I think are going to be the next superstars, because they know so many important things that I think has been underappreciated in industry so far. But I look at all these papers and they're amazing. They go nowhere, right? And so how do you get these superstar people that are working on the right problem, but they're not working at it from a translational perspective, and they're not de-risking the ideas early? And so I would love to see a culture change in science for the people that are working on the translational, future translational side, to de-risk that early. And then the other follow-up question is, what does it mean to fund things with a translational end and with a de-risking idea in mind? Because sometimes part of de-risking is the answer is this is a bad idea, and let's just kill it. So I think these are kind of riffing on what Sarah was saying. I think there's a lot to solve here. And I think this is where good industrial partners have a lot of role to play.
Yeah, I love the big if true framing, because I think, particularly for those of us who've worked in climate adjacent technologies for a while, there's a fair amount of jadedness, I would say, among the community, right? Because some of these things have been tried and didn't work out. And I think for me, it's always okay. The one barrier that is fundamental are the laws of physics, right? But other than that, there's actually a fairly large playground here to make changes. And when I think about what's changed over the last 20 years, certainly biological tools have gotten a lot better, but think of battery technology, think of wind technology. I think a lot of the the investments in all these different kind of pieces of the puzzle are really starting to pay off over that time. You mentioned rock weathering and geology. What do you think needs to come together? Let's say you have your I'm going to use a pun here, a rock star geologist entrepreneur. What do they need to know to bring their knowledge of geology together with other technologies to, build a demonstrator?
Cool. I'll try to answer this quickly, and then I'd love to hear Sarah's perspective on it. So the reason we talk about geology at all in the context of carbon capture is that the biggest process that naturally happens, or one of the biggest levers, is the process of rocks weathering. And that's the thing where the Earth is full of silicates. Silicates over time weather into carbonates. And so carbonates are a solid form of carbon. And so certain silicates will convert better into carbonates. The thing that's really interesting about this from a biological perspective is that biology has evolved in certain situations to help speed up that process. And if you want to see a good example of that, you just go to a lava flow and you see that immediately these lava flows degrade much faster than they would. And when you go scrape that, you see that there's a biological story that happens with these chemolithotrophs that come in to eat the rock immediately. It's not actually photosynthetic organisms that originally populate these fresh rocks, and then decades later, then in comes a more complex community. There's a lot of other examples like this, but I think that one is really illustrative. And there's great scientists that work on it, but it's done from an observational view, which to me is like biology in 2005, right, where we studied biology like we studied geography, right? It's just like memorized, but now we can look at biology as an engineering problem. So you can go to these people and you can say, great, like here's these populations. How do we culture them? How do we speed this up? I think the number that we need to target is 1,000-fold increase of this rate of weathering. If you can do it well, you can. There's a bunch of people that have done great work on this. Jennifer Wilcox, Bill Renforth, Gordon Southam, Greg Dipple, like just to name a few. I think synthetic biology has a big role to go in and really start hammering on the rock weathering problem. I kind of answered your question, but I should let Sarah run with it.
Well, and hopefully there are folks out there listening who have some ideas to send your way for driving that even faster. And Sarah, we're about to wrap up here, but love to give you the last word here. Particularly on the topic of how to work with potential entrepreneurs to turn science into action and to build companies. Any words of advice that you have for those folks?
Yeah, I mean, this is the biggest challenge of our lifetimes. And, to paraphrase what others have said, it's time to build. I can't imagine anything more exciting. These are the biggest markets in the world. I mean, we're talking all of agriculture, production of food, of materials like leather, of cotton, palm oil, meat. We need to replace everything that we make with petrochemicals. It's fuels, plastics, industrial chemicals. I mean, it's endless. It's a challenge. It's also an opportunity. All of those things are made with biology. Potentially, they could be made better with biology. And historically, we've approached, the carbon cycle and understanding how these products are made in a sort of observational way. Just like, imagine if human health was observational. We just saw what happened with disease processes. We didn't engineer solutions. We didn't help people live healthier lives and be better. We're sort of have been in that place in observing what's happening in the natural world and in human focused ecosystems like agriculture with regard to carbon storage and carbon drawdown. We've just been sort of looking at what's happening. It's time to see how we can intervene, because the alternative of doing nothing is really just not tenable. So let's put these tools to work. There couldn't be a better time to be an early stage entrepreneur. If you've got an idea, even if it's half-baked, we're glad to talk with you. We're glad to workshop it. We'll help you figure out what are the things, the proof points that you can knock down to get to that $1 trillion business. So Sarah at voyagervc.com, feel free to reach out.
Awesome. That's great. Sarah, Dan, thanks so much for joining us for this conversation. 20 minutes is not enough time. I'm hoping that there's going to be ample follow-up coming from this workshop today, but thank you so much for joining us.
Thank you for the opportunity, guys.
Take care.
Awesome. Thanks, everybody. All right. Next up, we're going to be talking scale up. So I'm going to bring on Cynthia, Garab, and Nelson to kick us off there.
All right. Good morning, everyone. So the next session is scaling carbon negative solutions. And luckily for us, we have Garab Chakrabarti from Sologen and Nelson Barton from Genomatica joining for this conversation this morning. Great to see you. So I just wanted to, before we get started, introduce myself. So I am a program director in organism engineering here at Ginkgo. I just celebrated my first year at Ginkgo, so great place to be. And before that, I actually was, I started out learning about synthetic biology, doing my PhD in the early 2000s on it when it was the very beginning, and then spent a long time as an academic in a chemical engineering department, and then decided that synthetic biology to scale, I really wanted to explore that in an industry setting, and so made the jump about a year ago, and I'm loving it, and I think this is the place to be for synthetic biology, being out in the real world and thinking about scaling. And so I'm happy to be talking today with some leaders in this field, in synthetic biology and scaling. And so I want to start out by inviting Gaurav and Nelson. Maybe I'll start with Gaurav to introduce yourself and maybe tell us a little bit about yourself and also about Sologen and how you're thinking about these things moving forward.
Great, thanks, Cynthia. Pleasure to be here. Gaurav Chakrabarty, I'm a CEO and co-founder at Sologen. My background, I'm actually a physician scientist, MD, PhD by training. Did not think I would be touching synthetic biology in my career, to be frank with you. My PhD work, I was studying pancreatic cancer, discovered some really interesting mutations that led to proteins that can withstand really high oxidation environments, i.e. peroxide. And what was fascinating was my co-founder and best friend, Sean Hunt, he was at MIT. He was finishing up his PhD in chemical engineering on production of hydrogen peroxide using noble metal catalysts at scale, really large scales. And we kind of just started chatting and realized that if we marry some parts of an enzymatic process with some parts of a heterogeneous metal catalysis process, there are efficiencies that you can get with throughput and selectivity that either enzymes or metal by itself couldn't get. And so the whole premise of Sologen from a technical perspective is to push the barriers of, well, how far can we take this chemienzymatic technology at scale? And it turns out pretty far in terms of what we're going after and the scale that we can go at. So we have 2 production facilities now in Texas, making a host of products. We have 4 products on the market today. Business is going quite well for us, and we're expanding. We call these bioforges, and we're expanding them in the United States and internationally over the next couple of years. And so obviously we focus a lot on sustainability, but I think fundamentally my mind is, I come from a chemical family, and I just think about cost of goods and how it impacts sustainability. And it turns out those two go pretty hand in hand. So that's my background.
Great, thanks. Nelson?
Yeah, good morning, everyone. Good to be here. Name's Nelson Barton, and I run R&D here at Genomatica. I've been here about 10 years. I've been working in development of sustainable products and processes for a little over 25 years, and have been developing the processes that Genomatica has. We've been working at very large scale for a number of years. Genomatica is all about basically helping brands and suppliers to meet these aggressive sustainability goals that they have all come out with. And essentially, we work in a variety of different supply chains. We make everything from bioprocesses for biodegradable plastics. We're most recently announced that we're working on both nylon and nylon 6/6, as well as working on coatings. And so we plug ourselves into just a number of supply chains wherein we develop bioprocesses to essentially become essentially the sustainable source for a lot of these brands and suppliers. And so, currently we are working at very large scale. We are making an impact. We are running, we license our 1,4-butane diol technology to Novamont, and they've been running since 2016 at 30,000 metric tons per year. And recently, Cargill and Helm announced that they are going to build a 70,000 metric ton per year 1,4-butanediol plant, investing over $300 million to do that. So I think, you know, the BDO story for us has been, you know, extremely exciting, because to have your technology, you know, go to scale once is interesting, but to have Cargill Helm put up $300 million and want to build a plant twice as big as what Novamont is doing is extremely exciting, and really demonstrates that you can take synthetic biology and biomanufacturing to scale in a really interesting way. And then most importantly, you know, we continue to push into other markets, and we recently announced that Lululemon is partnering with us around nylons, and we're trying to you know, push that process out into the market as quickly as we can, taking that to demo scale with Aquafil, who's been a very good partner in that field. And so I think, you know, for us at Genomatica, it really is working at metric ton scale, and pushing these large processes out there. And we are seeing that, you know, increasingly that there's more and more acceptance from brands and suppliers to move towards biomanufacturing.
Great, thanks so much. So maybe let's start out with a question on, since both of you have kind of spent and thought a lot of time on this, like, what do you think are the key learnings that are available, you know, that have come from your companies and other kind of things that you've observed in the field over a long time that are important for like de-risking and really scaling synthetic biology from the lab to the market?
I'd love to hear Nelson's thoughts on this. He's
Okay.
Yeah.
Yeah.
I think, you know, when it comes to the scaling, I think one, you've got to get it right the first time, right? I think and for us, you know, the BDO story, you know, we were able to take that process and actually run it at commercial scale for a short period of time through a situation that we had become available to us through using the DuPont Tate and Lyle propane diol facility, right? And so once we were able to demonstrate that we could reproducibly run at commercial scale, then, you know, that was the first key to getting then Novamont on board. Novamont then, you know, they a real innovative company. They had to take that gamble and say, yes, we're going to go build a plant, and they built it, and it was, you know, an extremely exciting time in 2016, because we fired up that plant and immediately started making saleable product, right? And so, you know, we had gone through the rigorous process of taking this thing to scale. We had made product, we had put it in the hand of the, you know, end users so that they could validate that this is a, you know, essentially drop-in replacement for a petrochemical, that you know, essentially the end users would see no difference between it and the petro version, except now you're doing it at a more than 50% reduction in greenhouse gases. So for us, the key was to get that first plant, Novamont, to run, and to run well. And now that essentially, you know, is essentially the plant that you know, all industries can take a look at and see that biomanufacturing can work at scale and very robustly. And I think that was, you know, that's been the key for us, is to really show that, you know, we've got that facility running, and now other industries are looking in that and saying, yes, biology can work at scale, and it's getting them to, you know, it's freeing up a lot of capital to move in that direction.
Awesome. Yeah, we took a scrappier approach. I will say that. So we, how did we start? So we started with, we went to Home Depot, built our first little reactor from PVC parts. And it was a small scale, right? It was like, I don't know, 120 tons a year, nothing, you know, nothing really exciting. But we didn't know if we were going to be able to raise another round of funding. This was 2017, so it was like, who, you know, the whole like capital structure around SynBio didn't really exist at the scale it does today. So what did we do? We started a cleaning brand that not many people know about, called Ode to Clean. And what we did with that brand was we made wipes and cleaning solutions with whatever product came out of we called it bioperoxide coming out of the plant. And the whole idea was not to be a cleaning company, but to use it to leverage and use as a execution tool to show that, hey, this team can execute from idea to some scale to market. And so within 3 months of launching, that brand got acquired by the biggest wipes manufacturer in the United States. But what we negotiated with that contract was a supply agreement that basically committed the acquirer to a certain volume, which happened to be 80% of the next scale up that we'd want to do. So we had the buyer for the chemistry kind of preset. So that allowed us to go and build the next plant with basically there was a prepayment that allowed us to do it. And then we scaled up, I would say, to 1,000 metric tons a year at that point. And the scale up was pretty fast. And then at that point, once we can demonstrate that we were providing value to these customers, even at a small scale, and we then scaled up again to a 20,000 metric ton per year plant. And the way we ended up doing it was we always just had our critical customers prepay for it to the point where we didn't have to worry about the capital requirements to some degree. And so much more scrappy, I'd say. I wish we had the foresight to think about working with like the Dows and the DuPonts, but honestly, not many of them would take us seriously. We had just started in 2017, so we decided to take our fate into our own hands. And so for us, the scale up story was, well, if we can't scale up beyond this, can we make a solid business case out of this? And so that was our mentality from day one.
Great. Just flashing a question on the bottom there. And so on the scale front, looking forward to any discussion. So how can we harness public capital for the massive public benefit that is decarbonizing and building climate resilience? Grub, do you want to start with that one?
Yeah, honestly, we haven't taken any public capital. Obviously, we've done some R&D work with the government and DoD. But like I said, from our perspective, we've just been focused solely on getting are we hitting the cogs that the customer needs and getting it to them in their hands? And by the way, the benefit of that is, hey, there's a sustainability upside to it. So for us, we're now starting to think about what the DOE could look like for many more of these bioforges, a lot of loan programs, but largely we've just let customers fund our work. Yeah.
Maybe kind of building on that, one of the things that I think is encouraging and exciting is that it's customers of Genomatica's that are kind of helping push things into sustainability. Like, I love hearing that you're working to help customers meet their sustainability goals. And so can you comment on how that's changed over the last few years and how you see that moving forward and really driving the impact in terms of climate that the companies like yourself, like Geno, can have?
Yeah, no, absolutely. I think, for a number of years, we've been doing this for quite some time. And I think earlier on, it felt much more like a push, right? That we're having to push the technology and go to the, essentially what we initially did would go to the big, petrochemical suppliers and show them that we've got a greener way to make the products they're currently making. But then what you've seen is this huge transition. Essentially, consumers now are much more educated about where everything they use every day comes from. I think there was sort of a lack of understanding of just how much of the things we use every day come from petroleum, right? And as soon as people started to recognize that, they started to raise that with brands and say, look, we want this to come from a more sustainable source. We don't want it to be petroleum if it doesn't have to be. And so, how can we get our hands on something that's friendlier to the environment, made in a way with reduced greenhouse gases and a lower burden on the environment? And so the brands then have picked this up, and it's working its way up the supply chain, right? So now the brands are, that they're saying, look, if this can't happen quickly enough through our suppliers, we're going to go directly and work with, companies like Genomatica to pull on this. And so we're seeing just a much stronger pull from brands to get these biomanufacturing processes built and get these supply chains, remade using biomanufacturing. And so that's where we say, this is how we feel that, we can really become the sustainable source for a lot of these suppliers and brands by bringing these biomanufacturing processes to scale as quickly as we can.
Are you seeing similar things at Solage and Grub?
Yeah, I think something has changed. I will say that. Like when we started in 2017, there was very little pull, I guess, from our customers on the sustainability side. So it feels like something has completely shifted in the last couple of years that we didn't anticipate it would happen this quickly. And maybe Nelson, you've seen it as well. But like all of a sudden, our argument on, hey, it's all going to be about COGS. Well, I think that's still true. I think now there is still this idea that, hey, maybe sustainability is really important. And so it's become more of a central point in a lot of our sales pitches and how we think about the technology. So yeah, something's definitely changed. I hope it lasts, to be frank, because it's good for business.
It seems like they were, for a time, it was very much like you can hit COGS targets or you can be sustainable. And it seems like those things aren't so far apart anymore. And there's been successes that show, right, biomanufacturing at scale is possible, right? So what would you say is advice for, new up and coming entrepreneurs, in the startup space that want to have an impact in biomanufacturing, especially if they would like to, want to have a big impact in climate and sustainability?
Yeah, I think, again, I'm probably the boring guy in all of this, but I think the way to think about it is like, definitely think big, but start small, act now. So it's basically like, what are the things that you can do with this technology that proves there's an actual business case for it? Yeah, maybe it's sustainability driven, maybe it's COGS driven. It doesn't so much matter. More so about, hey, is there something real here that can be a generational business that is going to drive a lot of cash flow for investors while also doing good for humanity? I think even if it looks like a niche market or maybe not that big, you have to just start. And so I think a lot of, especially scientists, I'm guilty of this, scientists, entrepreneurs think a lot about, hey, we have to like make this perfect. We have to get the business plan to be pristine and everything. But the reality of the situation is I really don't think that we have time to just wait for the big thing. We have to be focused on what looks incremental can become very big very quickly. So just start now.
Yeah, and I would say, for us, it's do that techno-economic analysis right up front. If you've got an idea, I mean, because we have the tools now in synthetic biology to move away from the question of, well, what can I make? It's just like, to what do I need to make, right? I mean, you can really focus on, what it is you want to produce, and then do that techno-economic analysis, and then side by side do the life cycle analysis, because I think together, you can get a really good handle on it. If I'm successful, if this process works as I draw up the entire process, not just the organism, but if I draw up the whole process and I look at the economics of that, can I compete with the petrochemical process? And I think that's the way we look at it. We don't get into any sort of wet work until we understand that if we are successful, here's what the economics could look like, and here's what a rough LCA could look like, and the impacts that we can have. And and essentially that techno-economic analysis drives everything we do once we do start the work, and we stay focused on that. And I think BDO is a great example. That technology is in the top quartile of any BDO production technology out there, and it's a very young process. There's still lots of room for improvement there. We're comparing ourselves to processes that have been running for 50 years of with continual improvement, and right out of the box we're in the top quartile. And so I think think big, but do that techno-economic analysis to understand what success could look like.
Yeah, I do love that. We have a phrase at Solage, and it's called math is free. It really is, right? So for me, it's always about like, hey, like, you're right. Don't step foot into a lab on any of this until you can whiteboard out, at least to some degree of accuracy, what the cost basis is going to be, what the mass balance is going to be. Because it's just so funny. I see like all of these processes that people come up with. I'm like, the mass balance doesn't even close. Like, where is this going? Yeah, I do love that.
So don't forget about good chemi basics.
Yeah, it's just like fundamental.
Yeah.
It's the boring stuff that I feel like I actually get really excited by, like all the boring stuff, because like if you just consistently do those boring things really, really well, you just look back and maybe in 30 years you build a great business, you know?
That's great. So I think James Wesley had a good question in the chat. He asked how painful was scaling from lab to commercial scale? And then I really like the second part, which is how, what kind of novel hardware, software, maybe even people needs that are really essential, to get these early stage ventures, to scale up and be successful. Grab, do you want to go with that first?
There's a lot of pain.
Yeah.
A lot of pain. I'd say the biggest pain for us was I mean, I might get kind of technical here, but like it was just really hard for us to predict the mass flow, like the actual because a lot of our processes require air or oxygen. It's just super hard to predict that because of the geometry of the actual vessel that you're going to make. So that was like, we were surprised sometimes in the good direction. Oh, wait, the wall effects on the tube and stuff were not as bad as we thought. And sometimes it was the exact opposite, where it was like, man, this is way worse than we thought. So a lot of the processes that we thought were great on paper and even at like a beaker scale just didn't make sense when you scaled it up. So that was like just ego crushing in the early days, because you're just like, oh, this is such a beautiful, elegant process, but it just didn't make sense from a physics perspective on the fluid mechanics.
So it's a science that becomes, or engineering, where the thing that you think is easy becomes hard when you really do it in real life, which I feel like is anyone who's been in a lab or tried to build something has run into that at some point. But it sounds like persevering and empirical approaches you figure out.
I think there's a strong argument to be made about once you understand like the actual unit ops, then you could do a lot of this stuff on paper, in my opinion. But I think until you really understand the fluid dynamics of whatever scale you want to get at, it's really hard to predict what that's going to look like, unless you've got really good computational tools, which goes to the second question. What's going to make this better is, well, if you had really good CFD parameters, and maybe you could actually predict a lot of these issues. I haven't seen CFD simulators that are that good yet, but I'm sure it's not unfeasible for those to exist.
Yeah, I mean, I think for us, the key was just really developing really robust scale down models so that, we could, work at lab scale with essentially industrial conditions at scale. And so, as a result of that, I mean, we've been able to take, multiple processes to multiple different facilities and scale them very quickly and very successfly. And I think it really, it's critical to have, a lot of chemical engineers around. And I think, you can, I think I still hear very frequently that, going to scale is like a black box, and no, it's not. It's chemical engineering, and you can develop robust scale down models, and you can get yourself very confident that you're going to be able to go to scale, and it's going to work as well as it has in your scale down model in the lab. And I think, that's where we put a lot of effort. And I think the other thing to make sure you do is don't cut any corners. I mean, do that robustness testing, try to understand, what are the things that might happen at scale, and how are you going to manage them if they do? And you can do all of that homework, in the lab, and be as prepared as you possibly can when you take it to demo or take it to a toller, so that, if there are surprises, you've already thought about them ahead and you understand how your microorganism is going to respond and how you're going to deal with it. I think a lot of companies get in a bind in that, their timelines get pinched. And so what gets pinched? The back end. And, before they go to scale, and you can't shortcut that part. You have to take the time to make sure you're ready to go to scale. And I say, if organism development took longer than you thought, or process development took longer than you thought, okay, that's fine, but you still have to give your scale down and your robustness testing the time it needs before you go to scale, so that you're ready when you do go.
That's great. Seeing lots of +1s to techno-economic analysis in the comments. I know that, obviously hiring chemies is a good thing. We've talked about that, but I think there's other workforce needs maybe for companies in this space. When you're thinking about scale up, do you think about those challenges and what you're looking for? And is that different than it was, 5 years ago, 10 years ago?
So the question is
Yeah.
on the chemi talent. Is that what you're asking?
No, like if you're trying to hire for your companies, are you now looking for people with different sets of backgrounds to do different? So, chemies are great, bioengineers, people with, software and hardware tool experience. All of those things are things that you need. Are there specific areas, you'd love to see more people with some synthetic biology training plus something else that's going to really help accelerate, companies like yours go to scale?
Got it. Yeah, I mean, I'm a physician scientist who,
Yeah.
who did not even, I did iGEM in undergrad, but I was by no means like going down a syn bio pathway. And I think I got really, really good at the technoeconomic side and really understanding the engineering side of the equation. I think that those things can be taught, but I think there is like just a baseline. So a lot of people are like, oh, that's not my area of expertise, so I'm not going to dive into it. I think it's more about how quickly you can adapt into, okay, I do have to be a chemi for this to succeed, and so like I'm going to learn everything I can about it and get mentors to help me learn through it. I think on the flip side of that is also the commercial team is, a lot in the chemical space. You don't necessarily have maybe in the high end you do have really technical salespeople, but in like low end specialty, borderline commodity chemicals, a lot of these guys are just used to selling based off of just price or a supply chain issue. Now we're having to train them on how to think about telling the narrative of a process and why the fundamental process is better and more important for the customer and how it's going to reap benefits for them in the long run. So I would say it's for me, it was just like, yeah, the technical understanding is important, but it's more of how quickly you're able to really learn some of this stuff and how rigorously you want to learn it. And I think that's what separated people, at least in our company, people who have been hyper successful versus people who have been moderately successful.
Yeah. Interesting. Yeah, I think a lot of the people I know that have been really successful in synthetic biology, right, like come from a broad range of expertise. I was a biochemist, then protein engineer, then microbiologist, then chemie. And so you bring all of those things together and, and now I'm in a more industry setting. So I'm trying to understand those commercial and BD side of things. And so I think that's why we always have a lot of fun. I don't know. Nelson, do you have anything to add on that kind of topic?
Yeah, no, I mean, I think, we do, I'd say, I mentioned chemies. I'd say like roughly 25% of my R&D team is chemies, but then we have a very diverse background of people and perspectives. And I think that's one of the things that makes us successful is bringing, people with different skill sets and different perspectives to the problem. And they all have a different take on it. And that's how we, then solve these very challenging problems we need to solve in order to develop these large scale processes. And so I think, right now, it's very helpful for us because we're trying to deploy, to have that chemical engineer push and rigor that we need. But I think, biology has been doing, extremely efficient biomanufacturing for a long time. And I think there's still a lot for us to learn out there. So more, bringing on people who understand microbial physiology more, because I think there's many more opportunities out there potentially to develop these bioprocesses in even a more carbon conservative way. Because I think, organisms have figured out some, very, very creative and ways to get things produced. And I think we only scratched the surface of the ways that they've figured things out. And there's a lot more to discover there that we can then harness and take to scale.
That's great. I think we probably have time for maybe one more question. And I guess maybe the place to wrap it up would be like a forward thinking, like, where do you think biomanufacturing, with climate is going to be in 10 years, as we harness these not yet harnessed processes and biology?
That's a I'm a bit biased as always, but I think where a lot of innovation is going to come is how we figure out how to integrate biology with the more traditional chemical engineering processes and technologies. Let's be frank, petrochemistry exists because for so many years because it's efficient, it can scale really well. The question for me becomes, well, how do we take some of the learnings from petrochemistry and marry it into a lot of the learnings into biology? And I think that's where a lot of innovation is going to happen. I'm not a all or nothing kind of guy when it comes to this. I think there's going to be some marriage of the two that's going to make us hyper successful in 10 years. And it's not going to look just like, oh, it's a fermenter that's doing their thing. Maybe it's a fermenter married with a metal catalyst, or a fermenter, married with some downstream process, where all of a sudden, yeah, we can call it symbio, we can call it whatever we want, but the reality is it's going to be a fusion of multiple different principles that have worked in the past. So it's not like a amazing, like inspirational statement. It's just, I think that's the reality of what we're going to see in 10 years.
Yeah, I think that's to some extent the essence of synthetic biology has always been like, let's put the modules together from biology or not biology, right, that work in order to do things that we couldn't do before. Nelson, do you want to have the last word on this one?
Yeah, no, I think we're gonna move to this, the vision of a circular economy, right? I mean, I think some of the things we're going to talk about, we're going to get to carbon capture. We're going to use renewable energy. We're going to be able to take things from materials and products from end of life and recycle them back in. And I think biology is going to be the key catalyst that will help us take those materials and feedstocks. Right now, not accessible very easily, but I think we're going to be able to grab those feedstocks at end of life, push them back in through a biomanufacturing process in a full circular economy. And I think that's going to, happen increasingly, and it's going to go to scale. And I think, that's all out in front of us. And there's a lot of different industries that are going to come together to make that happen.
That's great. Well, thank you guys so much. This has been a great talk. I think and really inspiring, and lots of stuff to do, and big impacts we're going to have.
Amazing.
Thank you so much, Cynthia.
Well, thanks very much, guys.
Thanks, everyone. That was great. Thanks, Cynthia. Thanks, Garab. Thanks, Nelson.
How do I exit?
Great. Yeah. And I think one of those last points is awesome that we love at Ginkgo talking about like workforce development. So Solugen, love the Cheller down in technical industry, people down there, they know what they're doing. So really cool. So let's talk more about other systematic changes that we need, or systemic changes we need. I'm going to bring on Jen, Kristen, and Maddie.
Hi, everyone. Welcome to our session on sort of systemic change. We're going to talk a little bit today about sort of not just the technology, but also the market forces that are needed to make these real, make these climate action real. So I'm joined by two brilliant women today. So I have Kristen Ellis from Lower Carbon Capital and Maddie Hall from Living Carbon, who I'll let introduce themselves in just a moment. I'm Jen Whip. I run our commercial team at Ginkgo. So I wake up every day thinking about how we can make our platform more accessible and really drive improvements with our customers to help them achieve the sort of business outcomes that they're hoping to. And certainly Maddie and Kristen are both out there in the ecosystem trying to make change happen. So Kristen, maybe we'll start with you. Why don't you tell us a little bit about yourself and what you're working on at Lower Carbon Capital?
Sure. Hi, everyone. So excited to be here. Coming and hanging out with Ginkgo always feels like coming home. So my background is in biotechnology. I've been working in and adjacent to biotech for the last 10 years. I started in therapeutics and diagnostics, as you do, after getting a degree in biochemistry from the University of Alabama at Birmingham. Was trying to take a gap year that has turned into a gap decade. So I never went back and got a PhD, but I've spent a long time working through different places in industry, from therapeutics and diagnostics to high growth startups. I was an early employee at Opentrons, thinking about, okay, if we actually do want to build a world on a biological platform, whether that's bioengineering or nature-based systems, what are the pieces that need to be put into place to make that happen. And so that is driven a lot of my career. I transitioned into working on climate full time. In 2018, the IPCC report came out, scared the living daylights out of me. And it was basically the part where they said, we're going to need to reduce emissions and do carbon removal. They may as well have been saying, in my mind, we need magic, right? But I could think of a technology that already eats carbon excitedly every day, and that's biology. And so I started to think about what are the applications of synthetic biology, biological systems, or bioengineering to climate change. Did a couple of fellowships, one with an NGO called Carbon 180, one with the National Renewable Energy Laboratory. And the joke I always tell is I successfully executed the failed entrepreneur to VC pipeline, joined Lower Carbon, where now I'm investing primarily in sort of nature-based solutions to climate change and thinking about areas where we can apply tools of synthetic biology to sort of change the tide on climate change. And that's everything from companies like Living Carbon that Maddie's going to tell us about, enhanced photosynthesis, but that's also chemicals. We invest in Solugen and a lot of other areas. So, yeah.
Great. And speaking of sort of harnessing the most obvious sort of source for capturing carbon, Maddie, tell us a little bit about Living Carbon and yourself and what you're trying to do.
Yeah, of course. Thanks, Jennifer. So I'm Maddie. I'm CEO and co-founder of Living Carbon, and we are a climate change biotech company with a mission to utilize the inherent power of plants to capture more carbon. Our initial focus has been on genetically engineering trees, specifically focused both on two things: photosynthesis enhancement, so improving the rate of carbon capture per tree, looking at different alternative metabolic pathways, and then also on storing that carbon underground for longer. I think synthetic biology has a really unique opportunity to improve the durability of nature-based carbon capture solutions, which I think it's very hard to do without some sort of combustion or synbio. My background is actually not in synthetic biology, but my background is in a lot of PhD wrangling. So I worked at a research lab called OpenAI. That's another ambitious company working on developing robots and neural networks that were as intelligent as people. So I like to think of my only skill as being wrangling PhDs. That's pretty much all I've got. But I did kind of go down a similar path to Kristen, where you realize all of this talent was there working on so many different problems, like machine learning and AI was like the hippest thing you could do in 2018. And then I got the opportunity, I've also spent some time in hard tech investing, to work on Y Combinator's request for carbon sequestration and carbon removal companies. I was like, oh my gosh, I remember reading about climate change in 2014 or in 2004 with The Inconvenient Truth. Nothing's changed. This is terrible. It's only gotten worse. And at that point, I couldn't stop thinking about all of the plant biotech research that had gone into model organisms like tobacco, Arabidopsis, crops, and thinking, well, geez, like what if we oriented this entire industry back to be around a problem that I felt was even more important than increasing food yield, but really focused on carbon removal and climate resilience and land use efficiency.
Yeah, that's great. I think a lot of people can relate to this, like nothing has changed kind of idea. And we keep talking about a lot of the same problems, and our technology has evolved quite a bit, but we haven't necessarily turned that into sort of meaningful change in the market. So I'm curious to hear, maybe from both of you, we'll start with Kristen, like what are some meaningful business models that can create change in the market, and how do we kind of ensure that those businesses are supported so that they can actually reach some goals or make the change we're trying to see? What are you seeing?
I mean, we're seeing a lot, and I don't necessarily think that there is as much innovation is in the business model as you might think. And I might be sort of looking at that sort of myopically focused from a venture capital lens, right? But the things that we think about are, do you have a business model, right? Like, do you have someone that wants to buy what you're selling? can you scale that really fast, and can it get really big? And when we talk about scale, right, we're talking about, you know, rebuilding entire systems. In some aspects, in some of the business models we're talking about, we're thinking sort of 10 and 20 and 30 and 40 years out from now and talking about rebuilding the Dow Industrial Index, right? We're talking about coming for the Haber-Bosch process. We're talking about coming for these really big, huge scale sort of commodity markets and systems. And the business model there, I mean, it goes back to some of what Gaurav was saying, is it's pretty straightforward, right? You have to do your technoeconomic analysis and build the model to see, does the thing that you're building technically work? Are you breaking any laws of thermodynamics? And is it actually going to scale to a point to have impact? One of the top line things that we add into the business models that we consider from an impact perspective, of course, we're capitalists. We want it to generate a lot of revenue and make a lot of money. We also think in terms of CO2 equivalents. When I think about scale and impact, I think how many millions or billions of tons of carbon emissions or CO2 equivalents is this going to reduce from the supply chain? And or if we're talking about carbon removal, can this actually scale to hundreds of millions or billions of tons of carbon removed long term? We don't just think about those things, right? Like I mentioned fertilizer, I mentioned the Haber-Bosch process. Of course, we want, you know, fertilizers that can help us grow food, that are going to have a lower carbon footprint. We also think about, for instance, okay, if we're talking about new ways of fertilizing our crops, we also have all of these extenuating ecosystem impacts like runoff and eutrophication. Is this technology also solving those problems, or are we reinforcing them? So that might not have been an exact answer to your question, but I think the business models are fairly straightforward. And I think one of the most interesting things is we're starting to see market pull and market pressure, particularly around carbon removal and carbon emissions. There are a lot of voluntary and compliance markets emerging that are actually putting a capitalist incentive on changing those practices. And so I think those are some of the places where we're seeing people aim.
And Maddie, like picking up on that about sort of like building something that gets to a gigaton scale, is that sort of how you landed on tree cell systems, or how are you thinking about sort of building scale and the technology that you're working on?
Yeah, I mean, I think like thinking about a gigaton frame is really inspiring, both to founders, but also to the employees that we're working with. I think we initially focused on tree cell systems because honestly, like genetically engineering trees and also like synbio for direct carbon removal it's not something that people are super familiar with, unfortunately. And so for us, the reason was, okay, like we know that there's a large existing market within the timber industry that already exists, right? We don't have to create that. So that was one of the reasons. The other reason was really because of the fact that you know, you have increased permanence with like secondary growth from plant species. And then it's something that captures people's minds and hearts. And I think for me, that was really important because it shows like a proof of concept of the fact that like we can use the R&D platform that we've developed at Living Carbon to work in multiple different species. So I definitely don't see trees as like the easiest thing to do or as like the end all for us by any means. But I think it's an important part of the story to tell, right? People have such an emotional connection to trees in their hearts.
And also, like shameless plug for you, I think you have some exciting progress on that was published this week. So hopefully people pick that up.
Paper on bioarchive,
yeah, something like 53% improvement on carbon accumulation. Super exciting. Thanks. Coming back to this idea that there are lots of corporate action, like people looking at carbon offsets, things like that you mentioned, Kristen. I think one of the things that I have found really interesting is this idea of Microsoft and Stripe are sort of buying carbon capture instead of carbon offset. I'm curious, like what kind of, do you see that as a signal in the market, or how do you see that playing out in the scheme of like different ways to build some capitalism around climate action?
I love this one. I have so many thoughts on this. I could rant about it for a long time, but I'll try to keep it brief. So In short,
mini ranch is good.
Yeah, mini ranch is good. I mean, in short, so we're kind of looking at two different things. When we talk about offsets, what's interesting about offsets is a lot of times the nature-based solutions. So, for instance, tree planting or afforestation or avoided deforestation. Those things tend to fall under sort of, and there are many others, right? But those tend to fall under sort of offsetting schemes. Carbon removal, in particular, has sort of started to come about as this idea of, okay, so let's say I have the Staples Easy button, I smash it, we've suddenly stopped all emissions. We still have all this extra carbon in the atmosphere that needs to come out, and it needs to come out of the short-term carbon cycle and go back into the long-term carbon cycle. So when we're talking about carbon removal, we talk about durability, we talk about additionality. So durability, how long is it actually going to stay out of the atmosphere? We talk about additionality. So is the thing that you're doing additional, or would it have happened anyway? And this is where some of the forestry programs get into trouble. We also think about leakage. So in biological systems, there's a lot of carbon flux. So maybe some carbon is escaping from another part of the system that we're not exactly keeping track of. And so carbon removal is, but very straightforward. We're trying to pull CO2 out of the atmosphere and lock it away in some term of durability. There is a signal around that market, right? And what I think that signals from the Stripes and the Microsofts and the Salesforce of the world, these sort of emerging leaders in the voluntary carbon removal market, is that lay people, companies that do not do biology and have not historically been focused on climate, are getting a lot smarter and a lot more sophisticated about how they're thinking about what they're actually doing with those dollars. They're interested in sort of offsetting or adjusting for their own emissions. They want to make sure that they're doing something real, quote, unquote, where a lot of offsets are sort of lagging behind or maybe even failing is that these things are difficult to verify in some of those schemes. However, I do think that, right, like the compliance market in Europe is the biggest carbon market on Earth right now. The voluntary market is approaching billions. The compliance markets are approaching hundreds of billions, right? There is a lot of money in this space. And so I think probably what's going to happen is the market pull there. I think there's going to be some market pressure from voluntary and carbon removal markets. I think there are going to be some incentives to start making offsets better. In general, I think there's going to be a lot of money that's going to continue to go into both of these spaces. And one of the things that we like to think about is how do we help companies tap into that? And how do we help sort of bridge some of the gaps in knowledge and build a strategy around which one of those companies should be targeting? How do they make their product? Again, I use the term real. It's a very basic term, but how do we make sure, for instance, that Maddie's photosynthesis enhanced trees are doing what they say they're doing? There's a lot of measurement, there's a lot of verification, there's a lot of reporting that's going to have to go into that. And so, you know, we're kind of setting the bar really high there, but I think it's really important to sort of have that discussion about those things.
Maddie, how does that feel from your side, sort of thinking about the potential customers that you might be interacting with as you grow your company?
Yeah, I mean, I think we've seen a lot of interest in some of the work that we're doing, right? Everything from individuals trying to offer me cash to buy our photosynthesis enhanced trees to, you know, large corporations. And I think for anyone that's working on a frontier climate solution, being measurable, verifiable, and having really strong reporting, it can only help you because you're already working on a relatively ambitious climate change project, right? The last thing you want to do is get critique around verification. Mm-hmm. And I think a lot of it, there is this gap though, right? Between all of the work that can be done in lab and then actually scaling these solutions and removing actual carbon, right? So much of this is predicated on economies of scale. So I think with customers that are purchasing carbon credits, we have seen some get really excited about certain ideas that might work, but the timeline is 5-10 years away, right? And then there's also sometimes some critique and pushback on ideas that, you know, might not, right? Like we haven't planted our trees in every single state across the US, but that doesn't mean that like we haven't also demonstrated with a high degree of evidence and verification, the increased photosynthetic efficiency of our species, right? So I think you have to both model really conservatively as a carbon credit supplier and think about, okay, actually, like if this didn't work, would we still be generating enough carbon credits to deliver on this project? And be really transparent, right? Like the last thing that I think these customers want is for people to overstate the technological readiness of their product or what they're working on, because that I think only sets a mismatch between like customers and what they're expecting from carbon removal and what you're actually able to deliver, which is the worst place you want to be, right?
And beyond sort of seeing customers move in a different direction, Maddie, like what else would you like to see from the ecosystem to support companies like yours? Like, is that more funding? Is it, changes in regulation? Is it something in sort of academic research? Like what would help like propel more companies in the space?
Ooh, that's such a good question. I mean, I think like there are a couple things. One is, as climate tech companies begin to grow, they're going to start having to procure like actually growth equity, right? A lot of them, I think Solugen is a perfect example of a company that is much further along, but a lot of these carbon removal technologies, they're relatively young. And so I think that figuring out how these companies will actually scale, how we'll get to having the same sort of project financing for carbon removal that we had for solar, we have for solar now, is a direction that I would love to see. I think also like, in terms of some of the regulatory questions around carbon removal technologies, I think that in the same way that like FDA has a fast track for vaccines, technologies like living carbon shouldn't be regulated in the same way that like a glyphosate resistant corn is regulated, right? There needs to be some sort of fast track path, not just for the work that we do, but for the work that a lot of people are doing to help facilitate more interest, right? Specifically in synthetic biology. And then I think the last thing is partnerships, right? Like using all of these platforms, such as the work that Ginkgo has done, and really reorienting a lot of resources around carbon removal. I think that there are going to be a lot of processes, whether they're industrial or new industries, that might have been able to continue to go through. Like I think mining is a great example here. It's very cheap to blow holes in the planet, right? I think Chris and I were talking about this before, but this new economy, specifically related to carbon removal, I think is going to make biological forms of doing the same sort of processes all of a sudden economically viable. And that I think is going to be really exciting. So continue to progress down that line as well.
And Kristen, similarly, what Maddie mentioned, sort of the role of regulations. How do you see the sort of differences between the levers of government support and regulatory versus convincing consumers to do something different versus voluntary corporate actions? Like, how do you see those playing out, kind of supporting some of the companies you're investing in?
I mean, I think, one of the things that, as Maddie mentioned, that we sort of, earlier on, I think, as recently as maybe 2 or 3 years ago, that we felt more like we were taking on is a certain amount of regulatory risk. I mean, a lot of the industries that Maddie pointed to, extractive industries, right, are heavily subsidized. Our current agricultural practices, our current means of producing energy, all of these are heavily subsidized. We think of those sort of in the bucket of regulations and incentives, carrots and sticks. It's not that subsidies are bad. It's that we want governments to be subsidizing better practices. We still want to produce all of those things. We want to produce them in better ways that cause fewer emissions. We want to do, things like carbon removal, right, which is a fairly new or emerging market. And so I think there is some market pull in certain sectors that is going to be created by consumer demand. One of the places where that's very obvious is in fashion and textiles, things that have an end product that people are actually consuming. Fast fashion is a big one. There are others, for instance, in carbon removal, where actually the early voluntary participants in those markets are actually sort of ahead of the curve, and they're not waiting around for the regulations and subsidies to emerge, and they're saying, okay, there's a better way to do this, and we want to get out there and figure it out, and we have the money to spend on it and are willing to spend that money. And so I think there's going to be a little bit of everything mixed in. I think that as time goes on, there appears to be, at least in our minds, less and less regulatory risk. Regulations seem to be moving in favor from, whisperings about, regulations around fugitive methane emissions to, the SEC floated potentially making companies, do climate impact reporting in their quarterly top line report metrics, right? So I think we're sort of seeing that change, and I think that change is accelerating. And I think part of that is because a lot of these big companies and a lot of consumer demand and a lot of volume and a lot of money is flowing into this space. And sort of sentiment is changing around those things. So yeah, I was about to kick off on another rant about a totally different thing, but that's where I'll leave that.
It's hard to not do that sometimes.
Yeah.
So in our last few minutes here, Maddie looked back and said, sort of from, what was it, 2004, nothing has changed. Leave us with your vision of the future. So fast forward us to 15 years from now. What does the business or the intersection of climate and business look like?
I think that it's no longer a question as to whether or not doing good for the environment is good business, right? Like, carbon removal will be as big of an industry as extraction industries, right? And we'll have a more integrated world, right? We talk a lot about circular economy. I think one thing that I'm super excited about are carbon farms that utilize all different types of CDR and carbon removal, right? So we're talking about a direct air capture plant that's on a former mine that is doing mineral weathering with, mine tailings, that also has a synthetic biology component to improve the enzymatic activity and the speed in which that mineral weathering occurs by planting, plants that are enhanced to do whatever sort of process has to happen, right? And then those products being used for something useful, right? Whether it's building materials. I actually got this idea from someone at Ginkgo. I was inspired, but we tried to create a little vision of the future in my background here of what we thought our office would look like in 15 years, 20 years. So I'll duck down, but that's the general aesthetic.
I love it. It's like the biosphere.
But I think we need more people that are focused on creating these optimistic futures of the world, right? Because this is this opportunity for the most mobilization around a crisis we've ever seen, right? It has to be bigger than what biotech has done for COVID. And the time to start was yesterday. So,
Kristen, what's your future?
Oh, I first of all love and agree with everything that Maddie just said. I think one of the reasons we get along is we can vibe on this kind of stuff. I think, one of my visions for the future is sort of we talk a lot of course we talk about value in sort of company building and venture capital, and I think about sort of a shift in what we value and how we value those things. That's kind of vague, but one of the things that comes to mind for me is this idea of, whatever you want to call it, it's all semantics, but ecosystem services, right? Thinking about ways, I actually find carbon to be a very good but very blunt financial instrument, particularly as it comes to nature-based systems. There's a lot more going on in biology, a lot more that our ecosystem does for us than moving carbon around between the short-term and long-term carbon sinks, right? It gives us food, it gives us oxygen. A plant, a tree, right, is a bioreactor that gives us building materials and shade and the air that we breathe. And so, I think that potentially, in the future, I would love to see a concept emerge around not just carbon offsets, but biodiversity offsets, thinking about the whole ecosystem and what it's actually providing for us. I hope at least that the future that we're going to build has us more integrated as active stewards and managers of ecology rather than seeing sort of human and nature as very separate. And therefore, the systems that we set up, whether we're talking about plants as bioreactors that grow wood or steel tank bioreactors that are producing chemicals that we need, that we are thinking systemically about all of those things. What are the feedstocks required? What are the outputs of those systems? And how can we more effectively manage those in ways that don't have such a detrimental impact on the planet?
I love it. These are futures that I hope to live in. I think we'll be able to continue the conversation in some of the breakout sessions. Thank you so much for chatting with me today. It was great to talk to you. And Kaz, I think maybe you want to tell people what we're going to do next.
Yeah, awesome. And I want to thank everyone again, all of our speakers and all of you. There's like, the chat is super active, and it's frustrating to be virtual because we can't like chit chat about every single thing every single person is talking about, but that's why we have the breakout rooms. And also, like, we're all friends here. You can find us on Twitter, you can find us on email or Zoom. And then also we have a handy link if you want to talk to the Ginkgo team specifically, and talk our ear off about what you're doing or what you want to do or what you're dreaming of. We want to hear it. And so thanks again, Kristen, for coming in from her vacation. We really appreciate that. Don't emulate that, kids at home. And then Maddie, thanks so much, and congrats on the paper yesterday. So with that, we're going to move to the breakout rooms, where each room is based on a theme. So just go check out the themes, and whichever one seems best to you, jump in. The Ginkgo team in each of those sessions will basically kick off the conversation, facilitate it. They'll share ideas that we've been having in these spaces, work we've previously done or work we're working on. And so the session themes are regenerative ag and resilient ecosystems, of course, carbon capture and sequestration. And then we also have one on low or negative carbon products. And then we have a fourth room if you want to just chat with us. And so the Wood Gang will be hanging out in there. So find us there. All right. Thanks again.